All right, thanks everyone for hopping on. We're gonna go ahead and get started. So, a little background. I'm Anthony Romeo. I'm a product marketing manager at Oxipital AI. Oxipital AI has been around for a couple years, but we spun off from Soft Robotics, which was a material handling company focused on picking different food products. Now we have a focus on the machine vision and using AI to inspect food products and either provide robot guidance to robots that are picking or some other type of visual inspection. I've been in the machine vision space for about 10 years now, and I am very familiar with traditional machine vision. One reason why Occipital AI kind of has a niche and really focuses in the food space is that there's so much occurring natural organic variability. So if you're mass producing iPhones, they're very highly repeatable. You'll know in each corner there's a certain distance where a screw will be. The screw will be the same every time in the same location every time. There is no CAD file for a chicken wing, right? Everyone's going to be a little bit different, and it doesn't lend itself to traditional machine vision approaches. Instead, what it lends itself to is AI training methods, specifically like deep learning. So instead of providing a machine vision product that requires the user to either train the system with traditional machine vision rules or aggregate a bunch of photos and label those photos, we take a little bit of a different approach where we blend 2D and 3D to take a full 3D scan of the product and use that to kick off some synthetic data generation to train our object models. So here's some object models that we already have ready, but the way we would generate these is we would start by taking a full 3D scan of the product. So I've got some chicken breasts here that I can show off, and we will take this in our lab and we have a 3D scanner and we will get a full 360-degree scan of this chicken breast. So now you can see in 3D space, it's a little bit nasty, but it's very real. You can spin it around. You can see the reflectiveness. We know all of the dimensional data for this chicken breast because we used a combination of 2D and 3D. So we'll make sure we get a representative number of these chicken breasts. We can get some bad ones that have a lot of trim or maybe some damage to the chicken breast. And we'll go and we'll scan a representative number. So maybe like 10, 20 of these chicken breasts, make sure we get some good ones, we get some bad ones. Once we have a library of these scans, we can kick off some synthetic data generation. So if you're new to AI, a lot of ways people have marketed the way you train these AI systems is you'll mount the camera in production, you'll let it run for a day where it's not doing anything, it's just gathering information. It'll take 10,000 images, and then some poor unlucky soul, maybe it's an intern, maybe someone's getting paid overtime, but they need to go and just say, this is chicken, this is chicken, this is not chicken, here's a box around the chicken. It is very time consuming, it is very error prone, and it is very tedious. This is such a prevalent problem in the current AI space that there are startup companies that are explicitly about training data, and they just hire people to make sure you have good data trained. We think that approach is very error prone, again, very tedious and very time consuming. Instead, we use synthetic data generation. So instead of taking a picture and saying, where is all the chicken? We will say, generate me a picture that contains 7 pieces of chicken. Because we're generating this as opposed to trying to detect it, we know from the beginning how many pieces there are. And we can say, all right, let's generate this scene. We can see our chicken falling on our blue conveyor belt. We'll let this settle and we'll take this image and feed this in as training data. What this allows us to do is it takes the human error-prone element out of the process. It makes it far less tedious as someone just needs to set up the initial parameters, click run, and they can go off to the races doing other things. They don't need to be actively working on their computer as the model generates. And you don't have some unlucky poor human manually labeling all these things. Now, another benefit to this synthetic data generation approach is it lets us much more rapidly iterate. So in this example, we trained with a blue conveyor belt. If our customer has a retrofit and they found this new conveyor system, but it's a white background, if you were using traditional machine vision or some new AI approaches, you would pretty much be back to square one. You would start acquiring all those images again. Some poor unlucky soul would be hired back. They'd have to start labeling all these images. Very tedious process. For us, we know that the chicken hasn't changed. It's still the same chicken that we're using. It's just the background has changed. So we change that environmental variability from a blue conveyor to a white conveyor, and we can kick off a new synthetic data generation that still has all the same customer parameters, except now the new conveyor belt is trained. This can be applied to if we're adding a defect. If we have a new defect we want to look at, it's much quicker for us to add it. If there's any lighting changes, I know lighting is very important in vision, and all systems require some sort of lighting specs, but I would say that we are much more robust to lighting changes than a lot of other systems out there. So once we have used this synthetic data generation approach, we will generate an object model that a customer can load onto their system. They don't need to do any training. They can load it on and it should just work. Now, that leads to another question. How do I stay in control? It might be great that I have a system that can identify these chicken breasts, but my process is a little bit different than the last person you guys sold it to. We totally understand that processes change, and we understand that it's very scary if your AI is a black box and you have no idea what's going on. So we try to provide a level of visibility and let the user really stay in control. So here we can see that we are looking at chicken breasts. You can see if we're picking them, here's where our gripper would want to go for the chicken breast. We can see muscle side versus membrane side. And for all of these chicken breasts, I have a ton of data that I can see. I can get the length, the width, the area, the concavity. I can go in and get the length, width, area of the rib meat that we have up here. It's a little bit smaller. We can go in and we create a recipe that the user has the ability to control, and the object model isn't going to change. The object model is still getting out the same dimensions for each piece of chicken. What will change is what it does with that information. So I'm going to go into our inspection rules and I'm going to add a rule, and I want to see the wrong side. So we'll add that. Now, when I go back to my test view, let me make sure I load the recipe. Go to inspection, add the wrong side, add the rule, save and exit, reload. So now when I go back to our test view, if we go to our inspection, we can see that this one was labeled wrong side. Now I see all these little segmentation maps, and those correspond to fat for the blue ones, and then this pink one is rib meat. These are probably ones that we also want to filter out. We don't want customers getting chicken breast with all that fat on it. So let's go back to our recipe. Let's edit. We can go to our inspection rules, and we can add a rule for low trim. So now here, it's going to ask us, what do we, the user, consider low trim to be? And we have a minimum fat area and a minimum rib meat area. So I'm going to go in and I'm going to say that both of these are 1,000 millimeters squared. So I will save and exit. I will reload this recipe. And now we did pick up the one that had the wrong side, but because we've added the rule, the object model again has not changed, but what we're doing with the object model is going to change. So now we can see that we've identified both of these as low trim. Now this guy has a big chunk up here of this rib meat, but we're not giving it low trim. Why is that? Well, if we go to pick view, we can see all the dimensional information. If we go to this chicken breast in question and we check out the rib meat, we can see that the area is not above 1,000. If it was above 1,000, we'd be flagging this as low trim, but the area of rib meat is actually 924. With that knowledge, I'm going to go back into our recipe builder. I'm going to go back into our inspection rules, and I'm going to change the minimum rib meat area actually to 900. So now, because it's above 900, it is going to flag this as low trim. Again, the recipe isn't changing here. There's no needing to get back in contact and have someone load a new recipe and the engineering integration of is it going to work, is it not going to work? It's just going in and changing rules with the recipe already working. So we're going to go back to our test view. We're going to see the inspection results. And now we can see that this one is also getting identified as low trim. So this is great for if you have multiple different end customers that have different requirements. You can load a recipe that has all the requirements for one customer, save it, create another recipe for all the requirements for another customer, save it, and then just quickly toggle between the two. It's also great if you have a new person in charge that wants to have stricter quality tolerances. You don't need to get engineering involved. You don't need to come and hire an application engineer. You can just go in and have the control all on your own. So once you've deployed to production, all of that data, we have a cloud service that you can see all the data getting piped up to the cloud. So here I have the last week for our chicken breasts, and you can see we inspected 131,000 units with this one system. You can see our yield is a little bit volatile, as we would expect. So the yield here, different than throughput, is the percentage of throughput that is good. So this is the total number of units that we're seeing, and this is of that total number, how much is good versus bad product. And you can see that both of these directly correlate. When there is a dip in the yield, there is a spike in the defect, which is what we would expect. So the defect breakdown, we have two different colors on this bar chart, and these correspond to our defective products. So you can see here that we are getting chicken breasts that are the wrong side. They're the muscle side up instead of the membrane side. But majority of our defects are due to the trim. You can see in this little 4-hour window, we had 638 low trim and only 193 wrong side. Here it's 571 to only 169. You can see the total, we have over 7% represented by low trim and about 2.5% represented by the wrong side. So as a quality engineer, if I'm going to kick off a Kaizen event to make our process better, I know that I'm going to focus on the low trim because that is a higher impact. Now, maybe there's a case where the wrong side costs a lot more money, and if we do the math, that makes more sense to target. But having this understanding of exactly what your process is seeing, the exact number of each different type of product and type of defect, really lets you understand your operational process and make improvements to that operational process. So if we want to take a look at all of our good product, we can view not only just a film strip of what was good, but we have histograms giving dimensional data on the product. So we can see here that most of the product was between 615 and 658 inches long. Maybe that informs us we can make a packaging change and we can spend less on packaging to make it smaller. Maybe we realize, oh, our packaging isn't big enough. We actually need to expand it. We're getting customers complaining about things that are coming out of the packaging, and this would justify it. So again, all of these buckets can be customized to be information that is meaningful to your process. And then at the bottom here, we have this film strip. This is really awesome. If there's ever any recalls or anything, we can go back in and we can see images of exactly what happened. Where did we start seeing this issue? Where did this issue end? How many images before and after do we see of it being good to be confident that the issue is stopped? And we can go in and get, again, all of that dimensional information, the length, width, volume, area for each piece of chicken. Now, in addition to the good product, we can go in and take a deep dive into some bad product. So let's take a look at the low trim. So again, we can see how frequent it's happening, where we're having areas of spike, where it's looking relatively good. And again, here's that film strip. So let's take a look, and wow, all of that rib meat. So this definitely is going to be low trim. We can also toggle on to see the fat. All of these segmentation masks are toggleable. If you want to see everything, you can turn it all on. We can go in and see, okay, there were 2 instances of fat, 1 and 2. The aggregate measurement is here, and then each individual component is down here. So you can see you would add these up to get the total. We can also see the dimensions for rib meat, and we can see the general overall object dimensions. Can also quickly navigate over here to any of our defects. So if we want to see the wrong side, you don't have to go back to that main page. You can just hop over here. And we can take a look at what's going on with the wrong side. There's no segmentation filter. It's just the whole thing is upside down. So you can see we get this wrong side inspection rule. So again, I think that this is really powerful from start to finish, where a lot of other systems require you to generate some sort of dashboard. They require you to train the model. They require you to make any edits. I really think that Oxipital AI and V-CortX, we've built a platform that is fully integrated and lets you completely stay in control. So let me go. I know we've got some frequent questions. Let's take a look. What products do you guys use? Okay, great question. So at Oxipital AI, we really have a focus in the food space right now. The reason being is that there's a lot of organic variability, and there's no CAD file for a lot of these foods. They're all slightly different. When these things are slightly different, it makes it very challenging for traditional machine vision. And because of that challenge, it lends itself to these AI methods. If someone were to come up to us and say, could you mass produce this highly repeatable part? We absolutely could, but I just think that there are other places out there that can probably do it for significantly cheaper. We really have a focus in these non-repeatable parts, and it's something that we know a lot of other people can't do or have real challenges with. I've seen another question. Where's the best place to get started with AI vision? Great question. So I know that in automation, a lot of people want to get started in replacing labor and install robots and get things moving, and all of that is great. I think, as I kind of showed off on this dashboard here, knowing where your biggest problem is very valuable. And I think some people try to dive in a little bit too quick, where they'll install a robot at a location to solve a problem, when in reality, there was a bigger problem that was more addressable. So here, if you have this big initiative to install robots to flip the wrong side of the chicken onto the right side, it's great. You're definitely going to save some money. But if you had installed inspection first, it's a lot quicker to get it installed and up and running. The lead times are a lot quicker than having a robot arm, and it gives you information of where to best install that automation. So I think leading with inspection and then using that inspection to inform where you go with further automation is a very powerful combo. So it looks like running out of time, but thank you everyone for joining. On that note of leading with inspection, we actually have a webinar coming up with A3 on April 28th. So if you enjoyed what you saw here, definitely join us April 28th to see why it's, let me go into a little deeper dive on why you should lead with inspection. Thank you everyone so much for joining, and hope you guys have a great day.